Next, we'll be taking up white box and black box testing. As we have discussed in the last lecture, that what is black box testing? The test cases are designed using only the functional specifications of the software. These are based upon the input output behavior, that is the functional behavior, but does not require the knowledge of any internal code. For this reason, this black box testing is also known as functional testing. Now, this black box testing, this can be divided into two main classification. One is equivalence class partitioning, one is boundary value analysis. What is there with equivalence class partitioning? In this approach, the input is partitioned in such a way that instead of testing the software with all the values, what we'll be doing, we'll be partitioning the inputs in the form of classes. That means instead of using 1000 values, we'll be using only some values which will be equivalent to testing the whole software with those particular values. Suppose this is done in such a way that the behavior of the program is similar for the input data belonging to the same equivalence class. That means if the inputs have been divided into three classes, then we will take three values from three classes, and testing the whole software with those three values will be equivalent to testing the software with the full value. The main idea behind this is to prevent the rigorous testing of the software. Now, there are certain guidelines that can be followed for designing the test cases for equivalence class partitioning. If the input data values of to a system can be specified by range of values, then we can take one valid value and two invalid values that will be equivalent to testing the system with the whole range of values. Now, if the input data assumes value from a set of discrete members of some domain, then one equivalence class for valid data input and other equivalence class for valid data inputs can be defined. Suppose we're supposed to find out the suppose we developed one function which finds out the square root of a input number which assumes value in the range of 0 to 5000. Then what we can do, we can define this in the form of three classes. One can be the values less than 0, one between the values 0 to 5000, one values greater than 5000. Then we can take one values from all these classes, and testing the software with those values will be equivalent to testing the software with these values. Suppose one value for less than 0 we have taken up as -5. 0 to 5000, suppose we have taken up 500. More than 5000 we have taken 6000. That means if the software will be working correctly with these three values, then it will be equivalent to testing the software with the whole values possible. One other example of this is boundary value analysis. What is there with boundary value analysis? We normally encounter that the programmers normally commit errors which are at the boundary values. Normally the errors are with less than equivalent to, greater than equivalent to sign. So what is specially used in boundary value analysis will be testing the software in such a way that it will be able to find out the errors which are present at the boundaries of a function. Suppose again, if we are supposed to compute the square root of a integer value in the range of 0 to 5000, then what are the various boundary values? We'll be testing this with 0, -1 and corresponding boundary 5000 5001. So this is what we'll be taking up for testing the boundary value analysis. This is all with the black box testing. As we discussed, in this we do not go into the details of the software, but we try to find out the errors from the specification only without going into the details of the software. But we have white box testing. What is there with the white box testing, also known as structure or glass testing? This is why this is called glass testing, because it includes the rigorous testing of the software by looking into the details of the software. Now, one white box testing is said to be stronger than other strategy if all the errors detected by if one strategy is stronger than other, if all the types of errors are detected by first strategy, this is also detected by second one, plus in addition that it is able to find out the other types of errors. When the two testing strategies that detects error that are different with respect to some type of error, then the testing technique is called complementary technique. This is schematically represented over here. Now here this testing strategy A is stronger than B because A is able to detect more errors than B. Similarly, A and B are called complementary testing strategy. Why this is so? Because the type of errors detected by A and B with respect to some type of error, these are different. So these are called complementary testing. There are many types of white box testing. We have statement coverage, branch coverage, condition coverage, and path coverage. We'll be taking up these with the means of examples in the coming lectures.